In this video, we want to evaluate the integral of x times tangent squared of x. It's a pretty good bet that when you have a trig function multiplied by some x term, you can expect integration by parts unless you see some other easier approach. So here I'm going to let u equal to x, and then dv, I'm going to let that equal to tangent square root of x, but there's no quick way to integrate this one, so I'm going to use one of the trig identities and replace the tangent square root of x by secant squared of x minus 1. Then I'm going to integrate with respect to x here. The identity we're looking at here is 1 plus tangent squared x equals to secant squared of x. Solving for tangent squared, we get this. Then I'm going to integrate on the left side with respect to v, so I get v. And over here, with respect to x, the derivative of tangent is secant squared, so this will be tangent of x. And the integral of minus 1 with respect to x is minus x. We don't need the constant here. Wait till we get to the end of the problem. So now we can start the process here. So the integration by parts formula tells you that once you set up your u and your dv and found the value of v, then the first part of the answer is u times v. So that's this product right here. So this will be u times v, though this will be x times the v, so this will be tangent of x minus x. And then it tells you that the next part is minus, and then you have an integral, and the integrand here is going to be v, which is tangent of x minus x times your du. So over here I have a u equals to x. Let's find du. This will be du. The derivative of x is 1, or dx, so we go ahead and write dx. Well, the du here is going to be dx. And then this is going to equal down here. Just go ahead and multiply this out. That's already part of the answer. So x times tangent of x is tangent x tangent of x. And then multiply here by x. X times minus x is minus x squared. And then here, distribute the negative here. So the antiderivative of tangent of x is ln of absolute cosine of x. And it's a negative. So actually the integral of tangent of x is minus ln of absolute cosine of x, but then you got a minus right here. So that minus becomes a plus. And then here we have a minus and a minus, so it'll be a plus. And it's the integral of x with respect to x. So this will be x squared over 2 plus your constant of integration. And then we can combine these two here. Let me just write it over here then. It's equal to x, tangent of x. Then add the coefficients here, the x squared terms. We have a minus 1/2 here, or minus 1 here rather, and a 1/2 over here. So this will give us a minus x squared over 2. And we have plus ln of absolute cosine of x plus the constant of integration. So we got the final answer as x tangent of x minus x squared over 2 plus natural log of absolute cosine of x plus the constant. And we were supposed to check the result. So let me just go over here on this side. So I want to take the derivative of the answer here and show that it gives me this integrand here. So let's start with the first part here. The derivative of x, tangent of x. So here we have to use the product rule. So let's do it this way. It'll be x times the derivative of tangent at secant squared of x. And then we go tangent times the derivative of x, and the derivative of x is 1. So this will give me a plus tangent of x. And then for this one here, minus x squared over 2, we just multiply through by the 2 here, bring the 2 over. The 2's divide out, subtract 1 from the exponent, and I get minus x. And then for this one here, of course, the derivative of the constant is 0. So for the natural log, the derivative is simply you put the value of the function cosine of x in the denominator. So it goes to the denominator, and you take the derivative of cosine, that's minus. So we have minus sine of x over cosine. But this right here is just tangent, so this is going to be minus tangent. And then I got a plus tangent over here, so plus minus tangent, those cancel out. And then over here for this one here, I take out an x here for this to factor out the x, and I get secant squared minus 1. And of course this is the identity for 1 plus tangent squared of x is equal to secant squared. So solving that identity for tangent squared, this is just tangent squared of x. And that's your check. This is the same thing as the integrand. So again, what we're using here, and at the beginning of the problem here, we're using this identity from trig, that 1 plus tangent squared of an angle, in this case it's x, will always equal to secant squared of that same angle. So you can say this, 1 plus tangent squared of x equals secant squared of x, or you can say secant squared of x minus 1 is tangent squared of x. Thanks for watching. We'll see you next time.